The first sign of a citywide blackout is rarely darkness. It is silence. Elevators stop between floors. Traffic lights freeze mid-cycle. The constant background hum of refrigeration units, HVAC systems, and data servers disappears almost instantly. Within seconds, an urban environment that normally runs on millions of synchronized electrical signals becomes an inert machine. What most people misunderstand about blackouts is that the danger does not begin when the lights go out. The danger begins long before that moment, during the fragile cascade of failures that make modern cities extremely dependent on uninterrupted electricity. Power grids are engineered for reliability, but they are also tightly balanced systems. When enough load shifts, lines fail, or substations trip offline, the protective systems designed to prevent equipment damage automatically shut down sections of the grid. Engineers call this a protective trip cascade. To the public, it simply looks like everything going dark at once. And when it happens in a dense urban environment, millions of people instantly lose access to the invisible systems that keep water moving, food cold, communication stable, and emergency services coordinated. What emergency planners understand, and what most residents never realize until it happens, is that modern cities are not designed to operate without electricity for extended periods. Water treatment plants rely on electrically driven pumps and automated chemical control systems. Cellular networks depend on powered base stations that only carry limited battery reserves. Traffic systems collapse into unmanaged intersections. Even natural gas distribution relies on electrically controlled compressor stations somewhere along the pipeline network. In other words, electricity is not simply another utility. It is the keystone that allows every other urban system to function. When that keystone disappears, a cascade begins that can turn a blackout from an inconvenience into a survival situation within hours. But here is the critical misunderstanding. Most people assume the solution to a blackout is simply to prepare supplies inside their homes. Flashlights, bottled water, canned food. Those items matter, but they do not address the core vulnerability of dense urban living. The real problem is not temporary discomfort. The real problem is system dependency. Urban residents rely on supply chains and infrastructure that function only when millions of coordinated electrical components operate continuously. The hidden tactic used by experienced urban survival planners is not primarily about stockpiling more supplies. It is about positioning yourself within the physical structure of the city in a way that allows you to operate when those systems stop. This principle is grounded in basic engineering realities. Cities are networks of dependencies. Electricity powers water pumps. Water pumps maintain pressure in distribution lines. Pressure allows multi-story buildings to deliver water to upper floors. Elevators allow residents to access those floors efficiently. Grocery stores rely on refrigerated transport arriving daily through traffic-managed road systems. Remove electricity, and each layer begins failing in sequence. Emergency management studies consistently show that during prolonged outages, the first major secondary crisis is not darkness or even food shortages. It is water distribution. High-rise buildings cannot maintain pressure without booster pumps. Treatment facilities struggle to maintain purification processes without stable power. Even if water continues flowing through gravity-fed sections of a network, the monitoring and chemical dosing systems designed to keep it safe may shut down. The overlooked survival tactic that experienced preppers quietly prioritize is relocation within the urban environment before systems fully collapse. Not evacuation to distant wilderness, which is unrealistic for most city residents, but strategic movement within the city itself. Specifically, movement toward areas that remain physically accessible and resource-tolerant during infrastructure outages. Emergency planners call these zones low-dependency corridors. These are neighborhoods or districts where basic human needs can still be met without high-energy input. They are typically lower-rise areas, older infrastructure zones with gravity-fed water systems, mixed residential and commercial spaces, and walkable access to multiple routes. These areas are not secret in any conspiratorial sense. They simply require an understanding of how urban infrastructure is designed. This precisely looking in this building for the most long-removing collapses within hours of a major grid outage.